Hello and welcome to a new episode of my Python Coding Challenge series. In last week's video, I set out a challenge. Calculate pi using 3 different methods. Well, today I will show you the first method I picked. That is to say, the Basel problem. This is a problem relative to mathematical analysis and was solved in 1741 by none other than Euler, who produced a rigorous proof that the infinite summation of 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, etc., is equal to pi squared over 6. So we can use this formula to calculate an approximation of pi. We can do this by first calculating the infinite summation on the right, then multiplying it by 6, and finally square rooting it. And that should give us pi. So as you can see in our code, we've already imported numpy. So now we can write def calc pi 1 for our first solution. Then we can say max num as a variable. And now let's go through the steps we described earlier. So first we can say pi equals 1 over numpy dot arange of 1 comma max num plus 1. The second step will be to square the denominator. So we can take the entire selection and square it. Then we will have to calculate the sum of all our fractions. So we can do this by saying numpy dot sum. Then we need to multiply the entire summation by 6. And finally we need to square root it. So we can say np.sqrt. And that should give us our approximation of pi. So all that's left for us to do is print our approximation of pi, and then we can also print the exact value of pi contained within the NumPy library as a comparison. Now we can run our code by pressing the F5 key, and then by calling our function on the right-hand side, so calc pi 1, we can calculate an approximation of pi using a maximum value of, say, 500 million. So what our function will do now is calculate the infinite sum of 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, etc., up to the value of 1 over 500 million squared, and then use the sum of those to calculate the value of pi using our formula. So we can run our function, and as you can see, we have been able to calculate pi correctly up to the first 8 digits. Not bad for a first attempt. As I'm sure you can guess, by using an even higher number, you can get more and more correctly calculated decimal digits of pi. However, make sure to watch out for next week's video, where we will discover more sophisticated ways of approximating pi, including a method actually used by modern computers. So don't forget to subscribe to the channel so you don't miss that video. As always, I look forward to seeing you next week, and until then, happy coding!